so these were the slides that go, well, let me just back up here one moment so we can see the overview here. Yep, so I think you all have seen this schedule for this evening. Paul has some slides and I'm going to show you his slides in just a moment. This is a view of the just completed restoration at Mill Creek, which we'll speak about very briefly. So I'm going to talk about the index, including bacterial work, and a little bit on Lake Waterford, and some highlights. And Tammy will come in and talk about this year's bacterial work. And then we'll go on. Brad's going to talk for a few minutes about construction site monitoring. And then our other keynote speaker tonight is Tim Tumblety from Anne Arundel Community College, who will talk about drone work. And then finally, we'll have some comments from the DPW folks about some work to be done on Cattail Creek sewer line. So let's see, here's the slide that Paul wanted to show you. This is here's the dam at Lake Waterford, and these are the downstream sites where all of the different eggs have been found. This is from this year, right, Paul?
Yes, let me talk a little bit about these four slides, or these three, to give it a little bit of background to this. MRA has actually been involved in the yellow perch.
Paul, you have an echo. You need to turn off one of your one of your computers.
There's nothing with us.
Okay.
I don't have a computer in this room.
There's no computer on.
Okay.
You still hear the echo?
Yeah.
Oh, man.
All right, try now.
All right, better?
Yes.
All right, so without too much delay, the Magothy River Association has been involved in yellow perch since the 60s. We did a restocking in the 60s. We worked with our partners with the community college in the 80s and reintroduced the yellow perch through egg sac replacement or transfer from the eastern shore. So much of the yellow perch today is kind of related back to that targeting time in the 80s. And then in around 2005, we got a little more active with yellow perch under the project of Habitat Protected Area. And we got a very disturbing letter because I asked for the Habitat Protected Areas in the Magothy, and they basically, DNR said, oh, the Magothy is a dead end species. And I had known for many years that the yellow perch spawn up in Lake Waterford. So we got together with the community college and actually collected some of the eggs, and turned out that they did spawn. So ever since, we have been documenting, and up on this upper right here, if you can see my cursor, these are the areas that we saw last year. And last year, we had over 300 egg sacs. And down here is a picture this year that we had taken. And you can see the jelly-like egg sacs and the yellow perch. Now, these yellow perch were down by Catherine Avenue. And we had a particular problem this year was that we had a beaver dam blocking the movement of fish. The beaver dam was located at Catherine Avenue, and it was blocking the proceeding of the fish up to Lake Waterford. We quickly made a call to DPW, and they came down and actually opened the beaver dam. And it only took about an hour for the fish to swim that 3,000 feet to the spawning grounds right by 648 and the dam. Now, every year we do, in fact, in January, we take the river's temperature. And this is MRA volunteer this past January with our YSI measuring the water temperature. When the water temperature reaches about 10 degrees centigrade, the fish begin to move up the stream to spawn. I have this wonderful video of the fish actually spawning, but I'm reluctant to share it right at the moment. But I could email it later, but it's really rare that you can actually see the female release the eggs. And we were able to do that last year. Now, sadly, I have to report that last year was another problem in that there was up here was Ecology Services. And Ecology Services is a company that picks up the trash for the county, and had a dirt lot. And every year the sediment would come down from that dirt lot and flow all the way down into Lake Waterford. And we actually documented that for a whole year of that happening. And I kept on calling the Department of Environment complaining, and they actually put a request about a year and said that they had to fix this sediment from flowing into the river. Well, Ecology Services ignored that request for a whole year and some time. And it was a $35,000 fine that they had ignored. And when we got close to this last year's spawn, because we're out every day measuring the temperature in the rain or whatever, we would keep noticing and documenting every day that that sediment was coming right out of their parking lot into the creek. Well, when the spawn finally came, the very day it came was a very heavy, intense rainstorm. And as a direct result of last year's intense rainstorm, the entire yellow perch spawn was compromised with sediment getting into these very jelly-like and delicate egg sacs. And the pictures weren't pretty. Finally, MDE finally came through and fined Ecology Services for the damage done to the yellow perch and to the habitat in this area, and actually fined them $2.5 million, which turns out to be the largest fine ever weighed against a commercial and industrial polluter in the state of Maryland. I figured we lost about $9 million of yellow perch. But the good news is, if it is good news, the state's moving forward with the lawsuit, and I am hopeful that if there's fines levied, one of the things that would be working with our state delegates is if there's some money to be levied to fix the stormwater problem along B&A Boulevard, and use some of the money, give that some of the money to fix Lake Waterford. So something good will come of it. I'm extremely excited this year because this year's yellow perch spawn, though, was kind of stagnated a little bit because of the beaver dam. We were able to do two things that we weren't able to do before. We were able to collect egg sacs down at the base here and move them up into Muddy Branch area. And remember Muddy Branch area from the video, it's a wonderful little stream that always runs clean, clear, and cold water. And if you recall, you see that picture that I use all the time with Jay Fleming with the yellow perch and the egg sacs off of it. That picture was taken right here at Muddy Branch. The other thing that we did, and we got permission to do from DNR, was to collect some of these egg sacs and transfer them down to Cattell Creek in the Berrywood restoration site. We're hopeful that these eggs will reproduce. And the good news is that I did ask DPW this year, as what they tried to do last year, but was too late. They did put a lot of hay bales right here at the point where the stormwater comes in. They were in place 2 to 3 weeks prior to this year's spawn. And the rain has had very minimum extent to compromising the eggs. So we are very hopeful. And on the better news is, for some reason, these yellow perch ain't no mountain high enough, have spawned in Cattell Creek. I calculated off my pier at least 11 egg sacs, and some of those egg sacs are right at the doorsteps of the Berrywood restoration site, which is extremely good news. And I'm not exactly sure why they spawned in Cattell Creek, but hey, that's cool. So I would also want to move on. Sally, you want to hit the next slide? Oh, yes. Before I get a little bit further, because we had such a little rocky start, I want to welcome State Delegate Sid Saab and Councilman Nathan Bulkey and Councilman Amanda Fiedler. It's a little bit rocky, so I really appreciate you stopping in and checking out the state of the Magothy. We've been working pretty hard all year, and it's our turn to kind of show you what we've got. So also with showing what you got, I have been working very hard in the last 2 years on a situation called Mount Misery. And I've kind of stepped on some toes, and I kind of like sit back, and I made the Pittman administration come deliver on a promise that they had made that they weren't going to give any variances and modifications. And this model that I made, it took me 4 days to make this model. And each one of these layers of cardboard are 2-foot contours. And each red mark is every 10 feet. And sometimes people don't really see by looking straight down on a flat map what you're looking at. Well, this Mount Misery is a site of a former Civil War fort. And this site up on the top of the hill here, there were 2 cannons and were manned by 250 troops from New York. It's a very thin knife edge ridge. And we were doing a living history video. And when I started the video, the neighbors kind of mentioned to me that there were going to be 2 houses put up on top of this hill. And I like shook my head and said, build 2 houses here, where, how? And because it's extremely steep slopes, extremely. On this side is the Severn River. This side is 50% or higher of a slope. And this side down here is the Magothy side. And I put in Old County Road down here. So this is where the road is. So we really looked into this, and we were frustrated because there are so many modifications and variances to this particular project that it really should have been dead on arrival. And the most important ones are that there's a reason to have steep slopes up here. They want to build inside the 25-foot buffer, and they also want to build to get to the top. They want to cut out half the mountainside. Like in this area, remove over 100 dump truck loads of soil. Now, what's interesting about this is that this was a Civil War site. And see these boys over here, this is a picture of the New York engineers that actually built Mount Misery. Now, this is not a picture on Mount Misery because they didn't have photographers at the time. I'm looking for it. But these people in this video or in this picture, and I wanted to read something here that was written by one of these troops, and it relates to Mount Misery, but it also gives you a little bit of a clue as to how steep the hill was. So this was Mount Misery was built in April 26th, but this report was a couple of weeks later on May 15th, dispatched back to headquarters. And it says, we, the engineer troops, and if you zoomed in this, I got this from Library of Congress, says New York 8th Engineers. So we, the engineer group, were detailed to build a fort on a godforsaken place called Mount Misery, which we completed. So they completed the fort, and they were glad to leave it in the hands of regular troops, where they were the regular troops. These guys were the combat engineers. And then they also said that this is relating to the steepness of the hill. If the enemy would try to take it, they would have a glorious time of it, for surely they would no doubt be whipped soundly. And, you know, these military people are not one for writing a lot, but it does say volumes just how steep this hill is. And another mystery about Mount Misery, if you look down here, there's a picture of Round Bay. and you can see Mount Misery, the hilltop here. One of the things that has come up in this research is that the name Mount Misery is a mystery. We had always thought, because if you read further in this dispatch, one of the things the troops were complaining about, these guys were complaining about, were the Arnold residents trying to poison them with Johnny cakes. They were not welcome in Arnold at all, the Union. But Mount Misery was named 12 years earlier, and it was charted on a USGS map in 1848. So it's a little bit of a mystery how Mount Misery was named. But the bottom line right now is the county has put the block on any future development plans for this site. And we felt that removing that much dirt will destabilize and be reckless, destabilize this whole ridge line. And then you would think of this, and you can kind of see this, is think of this little piece of property up here as the keystone in an arch. And if you have to remove that much soil from that arch, it's all going to cave inward. And this is what we think. And this actually now is what the county is beginning to come around with, because Pittman has made it clear that if modifications and variances are being approved from this day forward, they're going to have to demonstrate that that modification is going to improve the health of the river or the environment. So our biggest argument is, how is removing all the trees on this narrow ridge and removing that much dirt on the bottom of 100 truckloads actually going to improve it? So right now we're kind of in holding pattern. I don't believe this project can move forward. However, we are going to be moving forward. And one of the things I'm going to be doing now that I have a little more time is exploring what's interesting about Mount Misery. It's not listed as an historic site. It did play a major role in the Civil War. It helped move troops into DC. It is the site of the first combined operation between the Army and the Navy. It is the site directly relating to the very first in the world ever application of the armored train. So we're going to move forward and try to work with the county and the state to get this listed as an historic spot. We're also going to look and explore since it has been charted on a government chart since 1848, we're going to explore that it might have federal protection on the Federal Antiquities Act. If you look at Devil's Tower, there's no difference between Devil's Tower and Mount Misery in terms of a landmark. And this was a landmark. It's been charted on every government chart since 1848. It's on this year, it's on the nautical chart, it's on the USGS chart periodically. So that's where we're going to go with this. We'll keep our eyes on as this moves, or if they come back with other variances. But this is really good news, and I'm excited to be able to share this. And hope it wasn't too long, but I just wanted to give you a little heads up. All right, Sally, let's hear what you have to say.
Okay, great. Well, thanks everybody for coming. And, I think seeing those videos really, and, hearing what Paul has to say about the yellow perch really shows us how, how much we care about the Magothy, and it's our river, right? And we're going to do what we can to bring it back a little bit to its former glory. So this year, we're going to see that the water quality is not coming back as we'd like to see, but there are other aspects of our state of the Magothy that show some real improvement. So first, I'd like to talk to you about the Magothy River Index. So this is this three-part index that we've been calculating since 2003 to give a pretty clear picture of the health of the river. And it's a three-part index. The first part is the coverage by submerged aquatic vegetation, or SAV. So these are the rooted plants that are growing in from the sediments and come up into the water column, and are really important for providing habitat for fish and shellfish. They produce both food, food and habitat. They produce oxygen in the water column. They hold the sediments in place and can help control erosion. They're just really important parts of habitat. So the formerly the Chesapeake Bay program thought that the Magothy should have or could have at its best condition, I think 544 acres was the old number. Now they say, no, we can have 579 acres of grass. So they raised the bar for us a little bit for how much grass we should have. But we get our data on the coverage of grasses, primarily from the Virginia Institute of Marine Science. They do aerial flyovers of the river every year. And from that, they chart the acreage of grass. And then we also get some data, land truth data from Bayland. The consultants go out with the county contract for some of the creeks that are going to be dredged or that are slated for dredging. And so they give us their data also. So those are our sources of data right now for the SAV. That's the first part of the index. The second part is water clarity. You know, how clear is the water? So when you lower a Secchi disc down into the water, whether you're the county executive or anyone else, if you lower the Secchi disc into the water, you want to be able to see it at 1 meter, you know, about 3 feet. And that's the amount of light that's needed for the grasses to be able to grow. So that's our second piece of information, water clarity. And then the third one is dissolved oxygen. How much oxygen is in the deep water of the river, or at least the deepest water, right above the bottom. So this is going to be really important for fish and shellfish and invertebrates that are living there. So we want to see at least 5 milligrams per liter oxygen. So that's the 3 parts of our 3-part index. So then we take these 3 parts and we figure out what percentage of the time do we reach those ideal points each summer at each station. And then we take an average of those 3, and that's our final number, that's our report card. So, you know, we're down here now in the 20 to 40 range. But we can see here, we got some volunteers out, one with a handheld meter for doing the dissolved oxygen, and also salinity, conductivity, temperature, pH, all those parameters are measured. We got another one here doing Secchi disc depth. We got one writing down the numbers and a supervisor. So we have we have 5 teams of monitors that go out every 2 weeks from mid-April until mid-October. And so we get all these data and we bring them back together, and then we come up with our index. So here's the overall index shown for the last about 15 years. So over here we have the percent attainment of goal, and the dark blue is dissolved oxygen. So that's always our best parameter. So what this is saying is that, you know, between 40 and, you know, 70% of the time, we reach that 5 milligram per liter deep water oxygen level, depending on the year. And actually this year was a slight improvement from last year. So that's our best story, is the dissolved oxygen. Next comes the water clarity, the light blue. So the water clarity has not done well the last 2 years. You can see it reached a nice peak here in 2019, but it's gone pretty much straight down for the last 2 years. And the acreage of grasses, same thing. It was peaked in 2019 and it's going down for 2 years now. So that's the overall average. That brings us to a 23.4. But if you put all 3 together, you get this dotted line, and that puts us at a 23. So not the best that we'd like to see. So the question is, why are we seeing, you know, less than really good water quality in the Magothy? And the answer really to that is we have too many nutrients and sometimes too much sediment. And so where do those materials come from? Well, they come primarily from stormwater and septic systems. So nutrients come from the septic systems. Even a perfectly properly functioning septic system does not have any mechanism for removing nutrients, just bacteria. That's what they're designed to do. And this is a map now of the north shore of the Magothy. You can see here's you know, Celery Bay over here, and every one of these little red X's here is a septic system. So the North Shore does not really have any sewer at this point. The hope is that at some point there will be some sewer lines that will come down here. The South Shore has more sewer lines, much more sewer, fewer septics. But this is problematic because of the nitrogen that's constantly flowing into the river from these systems. And then stormwater is going to bring in both sediments and nutrients. So here's a graphic to sort of remind us about the issues with stormwater. So this is all of this water then that strikes any impervious surface. Well, strikes any surface in the watershed. And if it's impervious, it's going to run off. So whether it's a roof or a lawn or a road, materials that it will carry into the creek will be those which it encounters along the way. And if there's fertilizer on your lawn that hasn't been taken up by the grasses, that's going to be swept into the creek. Dog waste will be swept into the creek, and that's sometimes why we see high bacterial counts after the rains. And then, the one thing we might see is the oil, because that sits on the surface. But we don't see the sediments or the bacteria from the dog poop too much. But we do see them, on these occasions, like what you saw in the video just now. And also we can see it here. This is the headwaters of Cattail Creek. This was from a single construction site that was not secured before the rain came. And you can just see, it just turns our creeks into this milk chocolate appearance. So these are the primary problems now: stormwater and septic systems, bringing nutrients and sediment into the river, clouding the water and making it difficult for the grasses to grow, and therefore making it difficult for the critters to grow. You might think, well, what about all those sewer spills that we have in the summertime? So we have actually a story we can look at from this summer to try to understand a little bit about the impact of sewer spills. Because this summer at the end of July, we did have a leak at a pumping station on North Cypress Creek. So this was right across the road from where Kohl's and the giant shopping center are in North Cypress Creek. And there was a release of 64,300 gallons of raw sewage into the creek. So this was problematic for sure. And as soon as this was discovered, which is usually within a matter of hours, the county springs into action, and they hired Bayland to come and run a study to look at the impact of this spill. So they sampled they had stations both upstream and downstream from the spill on North Cypress Creek. And they measured the nutrients that you would expect to come into the creek from sewage, as well as the bacteria that you would expect to come in. So they measured these every day. And there was a slight, there was a bit of an increase for the first few days, and then they started to come down. And by 2 weeks, literally by 2 weeks, every single one of those parameters was back down to baseline. So we could say that for those parts anyway, for nutrients and bacteria, that was the length of the time that the spill was affecting that area. Now, we also have one of our regular monitoring stations just downstream from where that spill happened on North Cypress Creek. So the data that I've got over here show some of the MRA data that has been collected at that site over the last 3 years. So we have the 2019 is in blue, 2020 is in red, and 2021 is in green. So we can, and so this point right here is when the spill occurred in 2021. So what we can really see from this, I got to get rid of this part there. There. What we can see from this is that the, we can't. Oh, sorry. This is surface dissolved oxygen, and this is bottom dissolved oxygen. So it shows us that there was not a significant impact on oxygen levels in the creek after this spill. You would expect that maybe with the input of organic matter, we would see, decomposition of that organic matter, which should use up oxygen within the creek. But because it was flowing and shallow and aerated, we really did not see an impact either at the surface or in the deep water. So, I think we can, gather that it's not really the sewage spills that are problematic in the river. It's the 24/7 release of nutrients from septic systems that would be problematic. And just to show you how that context works, DPW gave us some data. They did some calculations and determined that a single septic system, that is a perfectly well-functioning septic system, releases the amount of inorganic nitrogen that would be present in 56,000 gallons of sewage, or actually total nitrogen, in 56,000 gallons of raw sewage. So here we have a 64,000 gallon spill. So that means that really only represents a little over one septic system. Well, of course, from a year's worth of material. But there are 13,200 septic systems in the critical area, and there are 40,000 septic systems in the county, but 13,200 within critical area. So we can, I think, really see that septic systems are what we really need to focus on here. So now we have the data from the individual stations, so we can begin to see where we have better water quality. So these are all the stations that are sampled every season, again, mid-April to mid-October. And so we have these 8 open water stations here that are sampled by boat. Get my mouse better fit here. Sorry. And then we have 2 upstream main stem stations that are sampled from land. And then we have another 18 stations all around here that are sampled by land. So let's take a look first at the open water stations. So the way this is set up, I've calculated the health of these stations based on just 2 parameters. That's the dissolved oxygen and the water clarity. Because if we, it's hard to, we wouldn't ever expect to see grasses growing in the deep water out here anyway. So I don't want to confuse that with the lack of grasses out here. So it's just based on those 2 parameters. And for those of you who've been looking at this for over the years, you would see that this is kind of disappointing because usually the open water is all in the green, greater than 40% doing really well. This year, we actually, they're in the 31 to 35% of the time attaining just, 5 milligrams per liter dissolved oxygen and 1 meter of water clarity. So that's problematic. All of these are over, well, this one here is, that's the F mark for, a saline mark. So that is not over a oyster reef, but these are over, this is the Dobbins by a reef, and this is the new Dobbins where all the reef balls have been put out. And this is over a reef, and this is over an oyster reef. And there's a small reef at Olmsted. So Olmsted, you can see we did get good water, this is in the green now. So this is actually really good water quality here at Olmsted. And then this is what's called MR6. This is actually the site that the county samples. And that looks pretty good. Oh, wait, sorry. This is the site that the county samples. This is one that's over a reef. So a little better water quality higher up in the river, interestingly. Less good down further. And if we go way upriver, we can see it's black all the way up there above the bridge. So that is, less than 20% of our attainment of water quality goal. And then, over on this side of the river where we've got lots of impervious surface, we always have issues with water quality here, and no exception. Here's, this is the Berrywood restoration site here, and Cypress and Cattail Creek and Old Ban and so on down through here. Here's our cypress, our 3 cypress. There's the North Cypress site and the main stem of Cypress. Here is Dividing Creek, which is actually looking pretty good. In the past, it has been not that good. And Mill Creek, interestingly, was really good this year. Last year, I think Mill Creek was in the black. This year, it's blue. And what's the difference? Well, they did do a restoration. They have done several restoration. The county's been working on restoration sites on Mill Creek for years now. Actually, I think there are more restoration projects on Mill Creek than any other creek in the county. And perhaps that's why. Look at that, good water quality. So that was great to see. Over here, Grace Creek, we've got you know, good and bad, right next to each other, North Grays and South Grays. And then up here in this Eagle Cove area, really good water quality. Well, I guess this is really Eagle Cove, isn't it? This is Silver Bay. Good water quality here, Cornfield Creek, and then over by the Eagle Cove. So mixed water quality tells us a lot that we're going to go on to talk about as we go through here. One of the things that I noticed this summer that was odd was that we had very low salinity this summer throughout the river, in the creeks and even in the main stem. So this is actually main stem data that's plotted here. We've got temperature over here in centigrade, and that hasn't changed too much over all of these years. Here's our salinity over here using this axis. And interestingly now, in 2018, you might recall it was a very wet year. We had, I think, 70 inches of rain in 2018 compared to our normal 50 inches. So of course we had low salinity then. But this year, we had just normal rainfall this year, and yet we still had abnormally low salinity. And so did the Severn and the South Rivers. So I don't know quite what this is about, but that's what we saw. And I think one of that may have something to do with our poor water clarity this year, because when we get these fresher water, we get a different set of phytoplankton, you know, the microscopic algae that grow in the water column. They tend to be more of the green ones that just kind of stay consistent throughout the summer, as opposed to getting those waves of mahogany tides that we often get. So that was one thing that was unusual this year with our water quality. Now for the grasses, this is the results from Bayland. Bayland was only able to do one creek in the Magothy this year, and that was up here in Old Man Creek. And they did find 7 acres of the early season grass there, the horn pondweed. So we were able to add that number to what we got from the Virginia Institute of Marine Science. And so they're the ones that do the aerial survey. So they have flown over, and they then look at the images they take from flying over, and they see the coverage of the grasses. So you can see most of the grass is here. We had about half of the grass this year that we had last year. So that is disappointing. Again, I think it's poor water clarity, makes it hard for the grasses to grow. So grasses are reduced. A little bit of spotty grass here and there, other than that, but most of it is up in this area. This spot over here, actually, I subtracted that from the VIMS data because this, although it looks like grass, is actually algae. And we discovered that when we were out doing some drone practicing this summer. So Tim Timilty, who's going to be speaking to you in a little bit, is going to talk about some of the work that he's been trying to do with using drone to look at grasses. And so I did tell VIMS about this, that this was algae instead of grass, but they have no way of telling the difference. So we're going to maybe we'll be able to tell the difference one day. We'll see. So that's where the grasses data came from. These are the grasses that we have in the Magothy. Here's that early season grass, horned pondweed. And then these other grasses are more of the later season grasses. So we have a good diversity of grasses in the river when they grow. I do some kayak survey in Eagle Cove. We did it in early August this year. So these are just some images we took. This is rupia or widgeon grass. A close-up of it showing this kind of structure that makes it very distinctive to be widgeon grass. And this is what it looks like when you're out kayaking. This is the milfoil, and then this is the redhead. Both the rupia and the redhead were in flower at this time. Little flowers sticking up out of the water. That's the only part that comes out of the water is just that little bit of flower. So when the grasses grow, they grow really well. Although you can see even here with all the grass here, the water still looks pretty murky. So we would do better to get some more water clarity there. So we are always happy to have people to go out in their kayaks and look for grasses. So we have the Chesapeake Bay SAV Watchers program, which is part of the Chesapeake Bay program. I did a training with them, so I can train people to go out and look for grasses. And so we did get a bunch of volunteers who went out and looked for grasses this summer. Their names are here. And we just ask people to go out once in the early season, say in June, to look for those early season grass, the horn pondweed. And then once later in the season, maybe August, September, even October would work because they last through them. And just get maybe take some photographs and maybe some samples if you can't identify it. And then just give us the latitude and longitude of where they've found. And we can use these data. We send them off to VIMS because they can't tell what grasses they have. They only can tell where they are. They can't tell what they are. And even the Maryland Department of Natural Resources this year has asked us to give them data on this early season grass. So if you're interested in that, let me know. And I'd love to have more people go out and take a look in their creeks for the grasses this year. Bacterial water quality. Well, this is now this is Operation Clearwater. Dr. Tammy Demansky now at the community college now runs this program. And these are the sites that she and her students sampled on the Magothy this year, wherever there's blue dots. So she had a good coverage around the river. And so she goes out, they go out either once a week or every other week on Wednesday mornings and collect water samples and bring them back to the lab. And the next day have the data on the enterococci. That's the bacteria that they count. These are bacteria that are associated with fecal waste. And they only survive for 1 or 2 days once they're in the river. So if they're present when they are collected, then that means that they were recently contributed to the river. And that means there's a source somewhere of fecal bacteria. So we use this for swimming water quality. We're looking for geometric means of less than 35. And so these are the geometric means for each of these stations that I've put here next to the station. And you can see most of the time, most of these are below 35, or at least you can't tell most of the time yet. You can just see this is the average for the whole summer. So there are only a few stations that were high. One of the things that was very cool was we sampled for the first time this year right inside Dobbins Island, where everybody gathers to swim and play in the summer. And, when you see the count of 2, basically that means we didn't find anything, but we can't really report 0. So we report 2. And so really the water out there at Dobbins Island was really good. And we had another 2 over here, right here in the main stem in the middle of the river, really good water quality there too. And the others are, I can show you a little bit more detail on what we see in this next slide. This takes those same sites, puts them on a bar graph so we can see individual sites. And I've separated these out now based on those in the absence of rain and then all of the data, which includes the rain. And basically what you can see is that when we look at those in the absence of rain, the numbers are generally lower. So, and here's that Dobbins Island one showing, basically whether it rained or not, it was always low, as well as that one at Longview. So this is, I think, important for us to remember that, there is a warning by the county, and we say it also through this program, that after a heavy rain, especially if you see the water looks muddy, it probably is full of bacteria and you don't want to be swimming there for 48 hours after a heavy rain. But most of the time that looks really good. As a matter of fact, if you do the index on the enterococci in the same way that I did the other numbers, that is, what percentage of the time do we reach that safe value of what's considered safe for recreational use of the water? It's 90% of the time. So we would get an A+ if we could use this for part of our index. And then to compare 1 year after another, here is the last 10 years. And we can see that, this is normally the case. We had a few, I think, here's that 2018 with that heavy rainfall year. And so we can see the high counts that came in the presence of rain. But generally, and I'm guessing probably 2015 was also a pretty high rain year. But generally, we see good water quality in terms of bacterial water quality in the Magothy, and it's suitable for swimming almost everywhere. So let's see, Tammy is going to come in now. Are you there, Tammy? Has Tammy been unmuted?
I'm here. I think I'm
Hey.
unmuted. Okay.
Hey,
Okay.
Tammy's here. So Tammy's going to talk about signing up for this season.
Okay, so hello, everyone. I'm going to make this very brief. The application form for this season is up at the Operation Clearwater Google site. It's posted here also. You have several ways that you can get that information to me. You can fill out the form online and email me the form and then just send the check separately, or you can fill out the check, you can print out the form and send that with the check. This year, I'm sorry, we're based on $30 a sample. That's $1 an increase from last year. A big part of that is being able to pay technicians that work with me over the summer and get training, and many of them are environmental science majors, to be able to support them in the work that they do and be able to pay them above minimum wage. We already started getting some applications for this season, and we're ready to start work in our new building on the campus. And if anyone has any questions, please feel free to reach out to me. One important thing we've found over the years that the check definitely gets made out to AACC Environmental Center, but the address to send it to, it's good to send the check or to send it in the mail to my name and then the new building address, the HLSB Health and Life Sciences Building 272, so that it gets to me and doesn't get lost in the black hole of the mail system. Yeah. So again, please feel free to contact me if you have questions. We'd like to get the forms by the beginning of May, but please don't let that hold you back. I know in some communities, working through the approval process can take a little while. We're always flexible with that, so please reach out. We can always extend that due date without any problems.
Okay. Yeah, I also wanted to add here that Magothy River Association is going to pay for some samples to be collected again at Dobbins this year, and also over at Beechwood Park, so that we'll have some more open water samples for you to take a look at this year. Okay, well, thank you very much, Tammy, and we're going to move on then to our next slide, which is I'm close to done here. I promise. I do want to do a little update on our Lake Waterford project. We talked about this a little more detailed last year. So again, this is the Lake Waterford with its 12 stations, and here is the dam at Lake Waterford. And we were just looking at where the yellow perch were down here. And so we did monitor again water quality in these at these stations this year, and again found very low dissolved oxygen in the water, which makes it very difficult for most of the fish that you want to catch are just not going to be able to survive in the lake. This year we also collected water samples for nutrient analysis and found that they are very high in the inorganic forms of nitrogen, nitrate, and ammonia. And these are the nutrients that really fuel algal blooms. So you may recall that last year we talked about how we collected these cores out in the lake and had them analyzed. And again, we saw very high nitrogen in those cores. Phosphorus, interestingly, is not so much of a problem here, either in the water or in the sediments, but it's a nitrogen problem. So we are concerned about the sediments that come in from this industrial area, as well as toxic materials probably coming from this industrial area, as well as the nutrients that come in from the watershed that really make this lake unsuitable for most critters that you want to see living there, and also actually make it a source of pollution for the river. So the county, I believe, as far as we have been told, they are planning to dredge the lake maybe 1 or 2 years from now. Paul and I have a meeting with the county next month, and we will be talking about that and find out more about it. But this is a continuing project then that we feel is important for overall, not only for Lake Waterford, but also for the river itself. Okay, so just some highlights of the year. These are pictures taken at the restoration site at Berrywood, which was completed a couple of years ago. And it looks fantastic now. We did seed with water celery grasses that we got from the community college last year. I guess this was seeded 2 years ago. And this is just coming back like gangbusters. It looks great there. And other grasses too. There are 4 different species of grasses there looking really good. So if those little yellow perch could just figure out a way to get a little bit over some of these rocky rapids here, maybe they would come all the way up there to spawn. We'll see. We did put some eggs, as Paul mentioned, we did put some eggs up here in the Berrywood restoration site, some yellow perch eggs. And so maybe those fish will be interested in coming back in a year or 2. I guess we'll find out. Also, Earth Day was we had a fun celebration out at Beechwood Park to celebrate this really intensive effort here to stabilize a steep hillside at Beechwood Park. And, you know, particularly Mike McGuire, we really want to thank for this. He brought his guys and his equipment and stone and put up these stone walls for us. And then the Craftons came out and, you know, got the plants for us and set them out, and then we planted them on Earth Day. So it was a really great restoration project. If you ever, you know, please, when you're driving in that direction, it's Pasdena, and it looks great. We also had a reef ball event at Cape St. Clair this summer, where mostly it was kids from the community who came and put together reef balls for us. And these reef balls go out into the site by Dobbins Island and provide habitat for fish and shellfish. So it will improve water quality in the river as well as improve fishing. And so this is a picture of a yellow perch. This is actually taken from this year, but we saw the same kind of thing last year where all these yellow perch are coming upstream to spawn. This is a close-up of what one of those egg sacs looks like. It's really amazing. And we did have good spawning of yellow perch last year and again this year. And then finally, just the restoration work that's done on Mill Creek. This is the part that's right across the street from the community college at Jones Station Road. And this was an area that in 2005 was the site of a huge sewage spill that set off a lot of these Mill Creek projects are stemming from the fact that this was a mess in 2005 and 2006. So this was when the restoration was still being worked on. We got a tour from the project director, Nasrin Dahlgren, and she showed us around. Here are 3 of our long-term Mill Creek and other creek monitors, Steve Troy and Mike and Trish Lehman. We went out and got a view of the restoration site. So it's looking really good right across from the college. So if you're ever going down College Parkway, you know, pull over there and come into Jones Station Road and take a look at it. It looks really cool. And the Magothy Greenway Park. So this is up again, this is Pasdena off North Shore Road. And we weren't able to have our first day hike in 21 because of COVID. And we actually didn't have it in 22 because of weather and COVID, but that's okay. We worked on the trails in the last year, and we've gotten them in really good shape, and they're very well marked now. And you can see we've got these 2 trails here, and this is where they are. So you can see them there, and it's on all trails now. I believe you can get access to it. If not, it will be shortly made available on all trails if you want to see it. And we're going to be working this year in 22 on some trails over on this side, because this is also part of the county property that belongs to Magothy Greenway. So again, really nice place to go for a walk in the woods. It's all wooded here. It's really lovely. Okay, so we have, you know, lots of people to thank, and more for sure. You know, we couldn't do this work without all of these people and without the support that we get from our members and supporters. So we thank everybody hugely. I just want to, you know, if you're looking to do some volunteer work, either water quality or grasses, contact me. Brad's going to come and talk about the construction site work. You can contact him. If you got some good stories for some people who have been in the area for a long time, this is Andrea Germain's contact. If you want to grow oysters, we're still doing the Maryland Grows Oysters program, so you can contact Paul about that. And of course, if you're not a member, join the Magothy River Association. It's only, I think, I think we did raise the price to big whopping $25. So it's really a good deal. And, you know, ways that we can, you know, help the river at home by basically doing work in our yards, maybe putting in a rain garden. If you've got a slope at all, that would, so you could catch some of the stormwater that would run off your yard, you know, reducing fertilizer and herbicides and pesticides, and, you know, trying to keep the leaves in place, because not only do they provide natural mulch, but they also support the insects that are going to be able to live along the edges of your gardens here. If you are one of those, if you live in one of those communities that's all on septic, there's a program now through the health department where you can get some, if the community is willing to go forward with converting from septic to sewer, the county wants to help. They want to assist in helping those communities make the conversion. So you can find the application on aahealth.org. And again, more ideas, if you're looking for more ideas on how to help the river and help the watershed, the Alliance for Chesapeake Bay has a lot of cool stuff. Okay, so that is, I'm going to stop sharing now. And I think we're not going to do questions at this point because I know we're running a little slow. So we're just going to move along, and we will have time for questions at the end. Also, I will say that, you know, the normal newsletter that I usually put together and we post on the website as a PDF for a lot of these data that I've just shown you will be posted on the website within the next couple of weeks. So you'll be able to go back and look at the data in more detail if you like. Okay, so now Brad Knopf is going to be talking to us for a little bit about the construction site monitoring work that's his project.
Thank
Are
you,
you there,
Sally.
Brad? Yeah, hi. So I think you can screen share now.
Okay, let me do that. Here we go. And we'll make this into the larger version. Oh, wrong one, sorry.
That's the oyster nursery.
It is.
I do have yours on my computer if you want. I can pull it up.
Now I have it right here.
Okay,
Um,
nice picture.
mhm. Yeah, here it is. And we'll go like that. Here we go. So one of the things that Magothy River Association has done for quite some time is, I think it's been, what, 12 years, Paul? We've had some version of a stormwater committee and different evolutions of it and focuses and whatnot. And nowadays, the primary focus is monitoring construction sites because, you know, we all like the garden probably, and when we remember being kids, dirt was wonderful, but it's certainly horrible for our streams. So quick byline there, exposed soil is pollution. And just remember this, if you spot a problem, you can always call 311 and the county will direct their people to work on it. Just a quick overview, I don't want to get too far into these numbers, but you can see nitrogen and phosphorus, which are the two primary nutrient polluters that cause algae, the green stuff and other wonderful colors that oysters eat, by the way, to clear the water. But construction sites and row crops, we always hear about agriculture being the worst, but they're neck and neck, as you can see, especially on nitrogen. But that's not the only problem with construction site. It's one of the biggest. If you see this coffee toffee color, that's mostly clay. And this, by the way, is Deep Creek on the south end of the Magothy into Cape St. Clair. This was caused in a very short time by the hiker-biker trail, unfortunately. And it happened before in the same area from a development called the Deep Creek Villas. Doesn't take long for construction sites to wreck a long time damage to these streams. And the terrible thing about that color is it's mostly clay particles. that are suspended. And clay is very, very tiny. It can even pass through silt fence. And as Paul alluded to earlier, it sticks to fish eggs and suffocates them. So we don't want clay in our water. And about the construction sites, these are a couple examples of terrible construction sites, because you can see this one in the upper left. They're tracking all that stuff into the street. It's obviously going down the street and into the water. The one in the upper right is actually on the creek with a steep slope. Very poor stabilization, in fact, zero stabilization. And what this one in the upper left is really missing is a stabilized entrance. This is the remnants on the lower left of a stabilized entrance. It needs to be a thick layer of stone so that construction vehicles can pass in and out without tracking the dirt. We have a team of 6 people right now traveling around monitoring currently 50 sites. And here's what they're looking for. You should have silt fence or stabilization around the entire project. And when a construction company starts in, they have 3 days to stabilize the interior. They have to stabilize the exterior immediately, whether it's with moats on a big site, silt fence on smaller ones. But the interior has to be stabilized quickly as well, unless active grading is going on, which sometimes they try to fool us and leave tractors on site. But as you can see, this is pretty well done. Just in the picture in the middle, pretty good amount of straw there. And of course, the sod grass is good. The fence is in good shape. This one on the right, it's harder to see because of the glare of the sun, but that's a pretty good job on straw stabilization. So we have the 6 active team members, and each one has either a whole zip code or a part of it. The Savannah Park one's so big, it requires several people. We also are fortunate enough to have John Peacock on board. He's the former chief of inspections and code enforcement for the county, and he's quite a resource to have. The insight that he can provide is invaluable. So sometimes we get a new volunteer and we could really use a few more. We talk about the codes and what you're looking for, and we send them around with an experienced member to have a look at what needs to be done. And we do keep an open line of communications with the supervisors. So you have the supervisors of the inspectors. The supervisors are the ones that we develop relationships with. If we spot something that doesn't look good and we keep an eye on it, if it's consistently a problematic situation, sometimes you gotta act fast. We reach out to the supervisors, and they have been very cooperative, and they'll send somebody out, and if need be, they'll put a work stop order on it. You hate to see that, the interruption of somebody's home going up, but this is on the contractors. They know what's required, and if they don't follow the rules, they have to follow the rules, or there are consequences. I have a PDF of all the rules. It's about 12 pages long, and they have to know exactly what they're looking for. They have to approve the plans and so forth. But we're just kind of checking up and seeing how things are going, just to keep some extra eyes on the situation. We keep track of it, and we compile our numbers of how many sites we've seen and which ones were problematic for our own purposes. And as I mentioned, we are always looking for volunteers, particularly in Savannah Park, but also in Arnold and Pasdena is wide open. So, and a real bonus would be somebody who could monitor from the shore. I do a little bit of that down in Cape when the conditions are right, but this is my email. If you have any interest in joining us, please reach out. And that is what I have for you.
Okay, thanks very much, Brad. All right, so we are going to move right on into Tim Timmelty is going to do his presentation now. I met Tim a few years ago when he came to the community college to run the drone program there. He teaches a couple of courses to students there at the college. And he never did send me his little intro. So I'm just going to say that I know Tim used to teach at the Naval Academy, and now he's teaching at Anne Arundel Community College. And he's going to talk to you about challenges of using drones. Take it away, Tim.
Well, thank you for the introduction. Sorry, Sally, for not giving you that when you requested. I would like to thank a bunch of people here right in the beginning. First of all, the Magothy River Association. This all is a product of your annual AACC scholarship, and Alex Thompson deserves a lot of credit for bringing us all together. I want to thank Paul Spadaro and Charles Germain for the inspiration for this idea. They were working with Alex as a student that was receiving the scholarship, and he was out there working with them, and it was their idea to approach the college about using drones for mapping subaquatic vegetation. So we took a look around. The Gibson Island community supported us with a day trip out there. I'll show you maps of several sites that we looked at, and they continue to support the use of their dock area by the old school for taking data for this project. I want to thank Dr. Domansky of the Director of the Environmental Center at AACC, Dr. Sally Horner, AACC Professor Emeritus, and Brad Alston is our Professor of Geography. So there's a lot of really smart people involved, and I am just a guy that flies drones. So I really do depend on all of the smart people that have background in environmental and mapping to help me solve and Alex work on this project together. So back in August, we got permission to go out on Gibson Island through the Magothy River Association, and we did 3 different sites, one out here at Holland Point, one at the Inner Harbor, and one at the Gibson School Pier. And we settled in on the Gibson School Pier. It's a protected area, and it doesn't require access to the island, and there's a dock there that gives us a great advantage for flying drones. I threw this up there just so people, my background is the aviation side of it. And as you get to the north end of the Magothy here, you do start entering BWI airspace, and there's additional rules for flying in Class Bravo airspace. But down here is all uncontrolled airspace, and we're able to fly and collect data on most of the Magothy. This was on the August trip. Dr. Runner was able to explain to me what subaquatic vegetation was. I did not know. We were able to see 4 different types that day. The milfoil, waterweed, and redhead grass are all in this picture, some widgeon grass. And then one of the distractors that we're going to find out that adds noise to our problem is algae, which is not as good as subaquatic vegetation for sustaining life and producing oxygen there in the water column. So the first thing when we went out looking, we used a Mavic drone, and we experimented with using a polarized and non-polarized lens, trying to be able to tease out the subaquatic vegetation. So in these 2 pictures, you can see there's just a comparison. There's not much difference really, but the dark area is the subaquatic vegetation. And as you get further away from the land, this particular program I used could not build a composite picture. And we'll do some things as we progress through this lecture to improve on that. We also had a Phantom 4 drone that we used here at the Gibson School, and this had a slightly better camera. So even though it didn't have a polarized lens, the camera is slightly better on the Phantom 4. So this was our first take. And this was in August. And then we went back and did a literature study trying to figure out how we can use drones better for finding subaquatic vegetation. So Alex Thompson, the student that helped, this is part of a paper that he has written and submitted to the college's scientific journal that will be published this spring on all the work that he did analyzing the data that we collected. And this was to show that right now VIMS does a very large area mapping of the Chesapeake Bay area, and the Magothy River is one of them. We currently have people out in kayaks doing individual mapping of areas, and we're hoping that drones may fill in that area between large area aircraft and individuals in kayaks, and maybe cover a larger area, but still with people on the ground being able to identify what we're taking pictures of. So this is the VIMS data back from 2020, and you can see in this Eagle Cove area, there is documented subaquatic vegetation. So this was a great place to start based on the data. And one of I showed you in the first picture, we did see some algae. This is one of our future challenges. This is over at Spriggs Farm on the other side of the Magothy, and we have the same type of dark pictures in a photograph, but this is all algae and not subaquatic vegetation. So as a future part of the study, we're going to see if we can start identifying the difference between subaquatic vegetation and algae based on some reflected characteristics of the water or the plant life. So I use a program called Pix4D that mapped the area. So it took a series of pictures over this area back and forth to map the entire area. And then working with our geographer, Brad Austin, he helped us start to look at these pictures. And for this initial study, we settled in on a single frame that had a good sample of right here by the dock. So we flew the drone right from this dock. This is from about 120 meters, about 400 feet in the air. We took this picture, and the black circles are showing subaquatic vegetation. And the red circle, you can't see in the photo, but we knew from standing on the dock that the subaquatic vegetation broaches the surface here. And it's going to come important as we look at some of the other analysis that we do. So from our literature study, we found out that the one way of analyzing plant life in water is using different vegetation indexes. So I have a specialized drone, a Phantom 4 with a Centera camera, and the special thing about this Centera camera is it not only takes pictures in the visible light spectrum in the blue, green, and red spectrum, but it has a secondary camera that takes pictures in red edge and near IR. So red edge at 720 nanometers is right at the edge of the visible light spectrum for the human eye. And then it has another lens or another process that is able to take a picture at 840 nanometers, which is in the near IR region. And the reason we use this is there are vegetation indexes. One that you may have heard of, the NDVI, the Normalized Differential Vegetation Index, is a common index used to locate plants from a photograph. And what it does is it uses both the NIR or the near IR reflectance and the red spectrum, and uses this formula to bring out plant life as opposed to other things in the background. And through the literature search, we came up with several other indexes to experiment on as part of this study. So I will show on the next slide here, NDVI is the Normalized Difference Vegetation Index. The GNDVI is the Green Normalized Difference Vegetation Index, and that uses the green band instead of the red band. And what this does, so the red band primarily detects vegetation. In crop health, they often use the GNDVI because it'll give you more specialized or more a closer variation to see if the plants are healthy or not. And then we found there are a couple other indexes that may be better used for vegetation in water. So there's the MNDVI, which uses the red edge and red frequencies, and then NDAVI, the Normalized Difference Aquatic Vegetation Index, which uses the blue spectrum, trying to remove some of the blue reflectance of the water and see a little deeper to see vegetation. So this is, all of this information is something that I want to thank everyone for challenging Alex and I to, hey, let's use drones to find subaquatic vegetation. I knew nothing about this in August, and Alex and I have learned a lot in the last couple months. So what we did was we used a program called ArcGIS to do some of these calculations and process the data. So these are 4 different pictures that are showing when you add and subtract those different frequencies, how it alters the photograph. And this is in a scalar form from dark to light. And what we see here on the coastline, you have lots of green and it comes up very bright. So once again, we called Dr. Austin over to West Campus from East Campus, and we asked him for some more help. And one of the things he was able to teach us how to do, and Alex did all of this work, he hand drew a mask to highlight where we think SAV is, and then drew another mask that excluded the boats and excluded all of the land vegetation. And so this way it would eliminate all of these highlights, which would you consider in signal processing noise. So we eliminate that noise by adding using these two masks. And then the process that we came up with was to compare where we think SAV is with the general water. And all we're trying to do in this initial study is to see what index would be or could be good for seeing subaquatic vegetation, and how can we build a workflow that can automate this type of information. So two of the best ones when you look at the pictures these are the two used for aquatic life. And you can see from now the subaquatic vegetation starts to show much brighter in the picture, which is what you're expecting from this. One of the challenges we have is you can see we still have a lot of noise in the photograph. So this excessive noise is something that we have to figure out, how can we process this so it doesn't see these bright spots as SAV. So what we did is we went back here and looked at and compared what we think we should find as bright spots in the mask compared to the full mask, so that we can see the percentage of good quality returns is what we were thinking at. And from our initial look on this, the MDVI seems to give us the highest pixel count in the SAV mask and reduces the noise. So right now, our initial look is going to be using the MDVI index for looking for SAV masks, but we still have a lot of work to do. And this was all part of an initial work that Dr. Demansky through the Environmental Center is putting in a grant, hopefully for the initial year, and if we do good work, follow-on years to continue this work. And so one of the things that we hope to do this next year is come up with a more efficient workflow so that we can automate this process, that it will take these photographs, it will apply the index, and then start calculating the subaquatic vegetation mass or area. We want to be able to cover larger areas. We would like to test different locations. And then this is probably the biggest challenge. You always have to have a challenge that, you know, may be too far, but we want to keep something that may be difficult, which is, can we break out a signature of SAV using these indexes that will identify SAV versus algae? Now, they're both green, and what all of these indexes are looking for is that green reflection. So it's been an interesting project. Alex, if he's here tonight, I want to thank him. He did all of this work. I helped him collect the data. He spent the last 6 months writing the paper, analyzing this data, asking questions to Dr. Demansky, to Dr. Austin, you know, to myself, and it's been a fun project. And thank you for letting me show you some of our initial work. And I'd be happy to answer any questions when we get to that portion of the show. So Sally, I'll turn it back over to you. And thank you for letting me talk tonight.
Okay, thanks, Tim. That was great. I think this is really a cool project, and I guess we'll find out about that grant pretty soon. And you know, maybe we'll be able to do some of this data, some of this work, even if we don't get the grant. But it will be really cool if we get it, and we will be able to support more students. So we didn't mention that, but we are the only environmental group that I know of that sponsors 2 scholarships to Anne Arundel Community College. And Alex has actually gotten it for a couple of years because he's been around for a few years. So that's great. So thank you very much. And we will get back to you with some questions. So we also have and James Howard, who actually I've never met either of these guys, these people. There they are. And they are going to talk to us a little bit about the, I see Chris Murphy's here. Yes, hi. They're going to talk to us about the some work to be done in a sewer line along Cattail Creek. So do you all have the ability to screen share? I see you're still on mute. Have they been unmuted? There we go. And there we go. Okay.
You can unmute.
All right.
Yeah.
All right. Great. Oh, so
I
Chris,
think Jimmy's gonna screen share if he can.
Yes, I'm gonna try to screen share.
Great. There you are.
All right. All right. Can you see that?
Yes, we can. Thank you very much.
Awesome. Well, first of all, thank you to the Magothy River Association for allowing us to present. I'm glad the perch are spawning upstream. That bodes well for the health of the Magothy River. We just want to go over real quick a project that we're going to be doing within the Magothy River watershed to upgrade a existing sanitary sewer force main. Real quick agenda. I know you guys have gotten a lot of information tonight, so I want to go quick, but then we'll definitely be around for the questions afterwards. We're going to go over the purpose, the background, potential causes of failure, what we did for project planning, the construction method that we're using, the benefits for the community, potential inconveniences, safety mitigation, and an overview of the schedule that we're looking at. So this project that we're doing to rehabilitate the Cattail Creek force main is completely within the Magothy River watershed. The sanitary sewer service area that this is located in is slightly larger than the Magothy River watershed. Starts up a little north of Severna Park over to Route 2 and all the way down, and then goes to the wastewater treatment plant, Broadneck Wastewater Treatment Plant on Login Road. So what we're talking about tonight is when we collect sewer from houses and commercial and businesses, it typically will gravity flow into collectors that eventually go to a pump station. And then that pump station is at a low spot, and then it will pump it back uphill to the wastewater treatment plant. So what we're talking about tonight is Cattail Creek force main coming from the Cattail Creek pump station. It picks up 4 other pump stations along the way and then empties into the gravity sewer in College Parkway before the Mill Creek pump station. So in Anne Arundel County, we typically treat 12 billion gallons of wastewater collected from over 400,000 residents per year. We maintain over 230 miles of force mains ranging in sizes from 2 inches to 42 inches. This particular force main from Cattail Creek was built in the mid-70s. It's approximately 62,000 feet of 24-inch and 11,250 feet of 36-inch pipe. Just some quick flow numbers here. At existing wet weather flows, 4,700 gallons per minute. That'll fill an Olympic-sized swimming pool in a little over 2 hours. And build-out flows at 13,000 gallons per minute. That would fill an Olympic-sized pool in less than an hour. So right now, the Cattail Creek force main is made of PCCP pipe, which is pre-stressed concrete cylinder pipe. It has a steel cylinder with concrete on the inside and outside, and then steel bars wrapping around the outside. In the mid-70s, there were some quality issues with the wire around the outside of the pipe, where they would degrade prematurely. There's also causes of failure for this is on the inside of a raw sewer main, you have H2S gases, which eventually corrode the concrete. And if you have corrosive soils, that could eat the concrete away from the exterior as well. So a typical mode of failure is spalling or cracking on the exterior. Once the wires are exposed, those will then get oxidized or rust. And then once a pressure exceeds what the remaining pipe can handle, then you'll have a rupture. And this is a typical mode of failure for PCCP pipe. So we started off in 2018 with Black and Beach looking at some different alternatives. We decided to stay within the existing alignment along Route 2 because operational requirements with the existing pump stations, less impacts to the private properties all along Route 2. The hydraulic impacts, if we were to go with a different alignment, and the additional easements and right of way that would be required. And using the existing alignment, we'll also have less interruptions to traffic. We looked at several different methods. As far as new pipe replacement, there was open cut and horizontal directional drilling. And then rehabilitation of the existing pipe, there's cured in place pipe lining, slip lining, and compression fit lining. And I'm going to go more into compression fit lining, which was selected because of the quickness of the installation and the least amount of interruption to the all the residents along Route 2. For the sequencing timeline that we're looking at here, we're going to look at doing improvements at the Cattail Creek pump station itself, which will take about 2.5 months. And then we will use those pumps at the station to do the bypass pumping for the beginning section of the force main rehabilitation. After the pump station work, we're going to install the bypass piping from Cattail Creek, behind Coles on Leland Drive, down McKenzie to the pump station, Big Cypress pump station, and then all the way down along Route 2 to College Parkway. And that should take about 5 months. Then we'll transfer the flow into the bypass, take a couple weeks. We'll video and inspect and clean the existing force main. Then we will slip line it with a compression fit. That would take about 4 months. Place a new main into service, remove the bypass, and then go into site restoration. So the yellow line here is the existing alignment from Cattail Creek pump station, and it goes, collects Big Cypress, then Round Bay 3, goes on to College Parkway, picks up Jones Station pump station, and then discharges into a manhole down College Parkway. And then the red line here is the proposed alignment right now that we're looking at for the bypass on the 24, and then the green is the bypass with the 36-inch. So swage lining or compression fit slip lining is basically we take the HDP pipe, high density polyurethane pipe, and we reduce the diameter by pulling it through a die, and then we pull it through the existing pipe, and then it relaxes and expands back to the diameter, the inside diameter of the existing pipe, and then it's fused together as it's being pulled into the pipe.
Yeah, I kind of picture it like a rubber band. You kind of stretch it out, gets skinnier, we pull it through, and then we let it relax, and it fills in everything.
Yes. So quick section view of the HDP being pulled into a pipe. There's a towing head. The brown is the existing pipe. It goes through a reduction die as it's being pulled into the pipe. And then once it's pulled in, either you pull it out further than it needs to be, you cut it, let it relax, and then you move on to the next section. So at every turn, there's an excavation pit. Here's Mackenzie Road. And these are the excavation and pits where we're going to have entrance and exits for the compression fit lining. So here's on the left is a typical entrance pit, and there would be the reducing die down inside here as it's being pulled in. There will be a laydown area where the pipe is being fused together. And then the exit pit where the pipe is pulled out. Typically there's about a section, a 20-foot section that's pulled out where it'll be cut, and then it would shrink back in a few feet into the pipe as it relaxes. So as we're doing that work on the existing pipe, we will have a bypass pipe starting at Cattail Creek, going along Robinson Landing, then down Leland, McKenzie, behind the Big Cypress pump station, all the way down Route 2 to Jones Station Road, and then finally into College Parkway. The blue areas show bypass piping that is going to be buried in a small trench for protection. The yellow areas are bypass piping that will be installed above grade, protected by a jersey barrier. and I have some examples for those coming up. We also will be doing 3 crossings of rivers or tributaries to the Magothy River, the North Cypress Branch, Cypress Creek, and Dividing Creek, and then Mill Creek is further down here. And that was good to see that you're getting good water quality numbers on Mill Creek. So a typical buried bypass section, we'll put compacted stone bedding down, put the pipe in, and this will vary. The depth will vary depending on what size bypass will be going in, but there will typically be a foot below and above, gravel surrounding it, and then temporary pavement above. For the bypass that'll be installed above grade, it'll be at the shoulder of the pipe with a jersey wall between traffic and the pipe. And this jersey wall would continue for the entire duration that the pipe is exposed. So Paul was at our last community association meeting, and he had some concerns about the potential bypass leaking. So we wanted to add some slides in here to go over those concerns because we know that those questions were going to be asked. And before I go into the slide, I just want to mention that, because of the age of the existing PCC pipe, a do nothing scenario would ultimately lead to a leak from that we don't know what area, but eventually that pipe would fail and spill into a tributary for the Magothy River. So the reason why we're doing this project is to make sure that that doesn't happen, and having this bypass is a part of that rehabilitation process. But some of the things that we're going to be doing to mitigate that concern. So the contractor is going to be responsible for designing or subcontracting out the design of the bypass to a third party. So it'll be a separate design that will get approved by the county. The contractor is required to have a spill response plan as part of their overall emergency response plan. And the spill response plan, the contractor will have to show the different types of monitoring that they propose. They're required to do visual inspections daily. We're looking at different ways of flow monitoring and pressure monitoring that would allow us to see if there is a no flow situation or a no pressure situation. Then we would be notified immediately and can go see if that is because of a leak or that it's just the pump station's not pumping at that time. All the bypass pumps have full redundancy, which means if any pump fails, it has complete backup. The HDP fusing technicians will all be required to be certified to be an HDP fuser. The on-site inspector will also have experience in butt fusions and will inspect all the fusions. The contractor has to perform a break test before any pipe can be fused together. And that's where they take a sample, they fuse it together. They cut out I believe a 2-inch strip, 2 feet long. They bend it all the way back to make sure that fuse is working properly. And they do that every day before fusing a pipe. Also mention that the actual fusion of the pipe is stronger than the pipe itself. It's actually rated for higher pressure than the pipe itself, if done properly. The contractor is going to be required to keep multiple repair clamps of each bypass piping sizes on site, so that if for any reason there is a leak, they would have it's a clamp that goes all the way around the pipe, and you screw it down, and that would contain the leak. And then all the existing pumps will have the high water alarms in case, in the event of a blockage, the pump will signal a high level alarm and the county will respond, as well as the contractor. So I just wanted to show some pictures of how the HDP pipe was put together. There's high strength adhesive, wire mesh, and then the high density polyethylene inside and outside. This is a fusing machine in the field. Basically, it's a hydraulic ram. This is a knife that cuts all edges square, Then the knife is removed, a heating plate is inserted. It heats it up the pipe to a certain temperature for a certain amount of time, depending on the thickness of the pipe and the diameter. Those times and temperatures vary. But then that heating element is removed. The hydraulic ram forces the pipe together at a certain pressure for a certain amount of time. And what you get is this nice double roll butt weld fusion. So the benefits for this community, for the Magothy River and the Magothy River Association, but it is nice to see the citizens caring about the local waterways and making sure that they're being protected. And that's what we're also doing here with the rehabilitation, because it's over a 40-year-old asset that we've seen problems with this type of pipe before. And like Sally mentioned, in 2006 at Mill Creek, we saw this happen. The compressed fit lining or swage lining is the fastest construction method, and it'll be the least disruptive to the residents and business owners along Route 2 and back in Cattail Creek. The HDP is corrosion resistant to the gases that we see in the raw sewer and the corrosive soil that will encase the pipe. The one thing that we see as a weakness of HDP is that it can be penetrated, but because we're pulling it through a concrete pipe, that concrete pipe is going to provide additional protection for the HDP pipe once it's completely, once the lining is completely installed. The compression fit lining, it does not rely on the hose pipe for life expectancy. So we will get the same life as a new installation, but the hose pipe does provide additional protection. And then we also will have a new wet well, new emergency bypass vault at Cattail Creek, which then we'll use the Cattail Creek pumps to bypass pumps for that station. And those are on our county SCADA system, so those are manned 24/7. The community impacts, we'll have some temporary parking impacts due to the excavations, so as the pipe's being pulled in and exiting each alignment that's being compression fit lined, and those will be coordinated with anybody that's going to be affected by that before the construction, and then a day before, and then during construction. Any bypass that is installed on grade will be dipped under any driveway where it's not buried. The trash pickup and mail delivery is not anticipated to be affected. There will be work done at the driveway at Cattail Creek. Excavations that are needed for more than one day will be covered by flush steel plates. And then the Route 2 turning lanes will be impacted short term during some of the excavations. So this goes more overall safety mitigation measures for the whole project. The maintenance of traffic plans, we will have to get approval by SHA and the county traffic division. The contractor will have to have an emergency response plan before any construction can begin. The above ground bypass piping will be inspected multiple times a day to prevent any vandalism or sabotage. We're also looking at additional monitoring systems to be above and beyond safe, because we know the sensitive nature of these tributaries to the Magothy River, and we want to go above and beyond what we would do on typical products. I've done over 20 force main installations and have had no issues with the bypass pumping, but we want to go beyond what we would typically do just to ensure that we're not going to have any issues. We also have full-time on-site third-party inspections. We'll have a contract. The on-site inspector will be with the contractor at all times. If a resident or a business owner has any concerns, they can find the on-site inspector, ask them. If that question or concern cannot be addressed, immediately by the on-site inspector. They will then contact myself or another project manager, and we will get involved to resolve that issue. Expected overall schedule. Right now we're in construction documents, getting ready to head to bid documents. We're hoping to bid this out and advertise it in the fall of this year, which would put us at a construction start date early 2023 and an end date of mid 2024. And then we have a year warranty where the contractor is responsible for anything. Usually this is restoration related a year after contract conditional acceptance is granted. So I just wanted to thank the Magothy River Association for letting us come and present. We value the stakeholders and the communities that we're serving, and we want to include them in the process of doing these upgrades. And I will send a copy of this presentation to the association so they can send out to all the stakeholders, and you'll have all this information of who you can contact and ask any questions to. So thank you very much for allowing us to share.
Okay, thanks very much. That's going to be quite a project. It won't be fun, I'm sure, but it needs to be done. So I'm really glad you guys are on top of this.
And thank you for adding a few little parts in there about the security. It was, you know, when I saw the presentation at the Greatest Vernon Park Council, I was a little bit concerned over a few of those, points as they cross the very sensitive areas, especially Cypress Creek and those other creeks there. So
at each of those crossings, it'll be within a trench that will be visually inspected each day. And then we'll have an additional monitoring system, whether it be pressure, flow, to see if the pressure or flow stops for any long duration.
Well, I'm more concerned about the exposed line.
Yeah.
That's having some car or something hit it.
Well, and those will all be protected with concrete Jersey barriers.
Yes. Well, thank you. I appreciate that a little bit extra because I think, we're the Magothy might have some issues, but we think it's pretty good, and we're working to always make it better, and I know you guys are too. So I just appreciate that.
Thank you.
Okay. So I guess maybe everyone wants to get up now and stretch, maybe grab a beverage of your choice. And we have some time for some questions. I think we have all of our speakers. I see Tim and Tammy. Yep, there's Tim and Tammy, and you guys are here, and Brad is here. So I don't know, have we had questions coming in during chat? I haven't had a chance to look at the chat to see if there were questions that people would like us to answer.
Hi, Sally, it's Lise. I'm unmuted now, so I do have some Okay. First of all, this is for Sally or Paul, or if there's anybody left on the call from the county. Howard Weinberg was asking, how is the stormwater tax money being used to improve the water quality in the Magothy?
Oh, well, do we have a county rep who'd like to speak to that?
I'll briefly speak for a second. We don't have the appropriate people on board to answer that question.
Right.
Yeah, maybe invite Eric Michelson. I'm sure he can come and tell you all the good projects that we're working on. I know we did do a project recently because utilities worked with the stormwater folks on Forked Creek. We did a stream restoration over there in Arnold. I think I suggest that you guys invite Eric Michelson to come and talk. We can let him know.
Right. I know there have been a lot of restoration sites that have been carried out on the Magothy. You know, as I mentioned earlier, I think Mill Creek alone has had more restoration projects than any other creek in the entire county. And that a lot of that is due to, because of that big spill that happened in December of 2005. So, but there have been a lot of projects done in the Magothy, and I think certainly the Berrywood work is a great example of what can be done with an eroded stream bank, and it turns out to be a really lovely stream in the end.
Yeah, I
Restoration
think
is great.
when you look at the overall Magothy River, Berrywood kind of sticks in my mind. I mean, I was a little disappointed yesterday. Those yellow perch laid their egg sacs just inches away from getting into the upper part of Catfield Creek, but when you actually get into the restoration site, you'll see how well it actually has been functioning, and it's well studied. I know just ran into a bunch of Towson grad students that are doing a study, and I know the University of Maryland's doing a study. It's been well studied, and there are a lot of positive things coming out of that. And the other part that's significant with all these restoration sites is that they improve that local area of the habitat that was degraded, and that I think is part of the problem that we have to deal with as we move forward.
Okay, we have another question from Craig Myers. And I think this one was pretty well answered by Brad already, but I'm going to throw it out there. What can waterfront homeowners do to promote underwater grasses? And Brad, of course, said reduce or eliminate fertilizer. And I think that's really the number one critical thing we can do. Are there any others you or Sally have, Paul?
Well, we have found that the grasses are quite specific in where they can grow. If you have an area that has a lot of fetch, a lot of area for wind-driven waves to approach the shoreline, grasses won't do well in those areas. They need a little bit of protection from the wind-blown waves. And you need to have the right type of sediment. It has to have some sand in it, as well as some mud mixed in with sand. It can't be all mud. That won't work. So there are some specific requirements, well, of course, as well as light. And the light is the key, that one of the things that we can really impact by reducing nutrients. We can reduce the amount of algae, which would increase the amount of light. So, and areas that look like they can tolerate grasses that maybe had them in the past and don't have them now, those are areas that we can seed. But seeding is tricky because just the supply of seed is very limited. And the community college has done a lot of work on ways to harvest seed from grasses and to store it properly over the winter and make it available for planting in the spring and summer. But they have very limited supply. So, it would be really great, if we could get, there's been some talk. I just sat in on an SAV conference the other day for the Chesapeake Bay program. And there is interest now in possibly funding for a nursery. There's talk about building a nursery where grasses could be grown and seed could be harvested. It could be used for restoration. So that's still years in the making, though.
Another component that's left out of the discussion too with the underwater grasses is actually improving the water clarity by putting in more oysters into the river. The Magothy has been very much on the short end of a stick for the past 10 years, because while we initially started out with a large number of restored oysters, the Magothy was for political reasons dropped off a priority list for oyster restoration. So our oysters, we've well documented them that they live from 7 to 15 years, but it's been almost 15 years since they've been reseeded. And we need to have our beds reseeded. And it's one of the things I need to work with some of our state delegates and some of our county councilmen, is to put the Magothy back on the priority list to have these filter feeders in the river, which could help improve some of the visibility. I'm sad to say that, you can go to the Severn River, and when you come back to the Magothy, you can clearly see the Severn is much cleaner than the Magothy. And it's not that we're doing anything really wrong. It's just that we're not putting enough effort I don't know what it is really. It's just sad to see. And I think we need to reverse that trend. We need to start doing more of the positive things that we know work. Putting oysters in the water. The other thing that I really want to stress tonight is that we really need to put the trees back in the critical area. I would like to work with our county councilman to reinstate having a permit to take a tree down in the critical area. Those trees remove nutrients, and without those trees, the nutrients are just washing in, and we need to do what we know works. So that's one of the things that work is those trees, those big oak trees and things like that. They do remove the nutrients, and it bothers me when I see a tree company pointing a finger up and saying, "Oh, that tree is sick." Well, it might be sick, but you don't get put down if you have a toothache. So, I mean, these trees really do function, and we should try to keep as many as we have. And I guess I'm going off on a tangent, but I was really thinking that's what we need to do. Lisa, got any more questions?
Yes, and that was pretty good, Paul. Okay, let's see. I've got another question from Tom Hampton. Is the focus on nitrogen deposited from auto and small engine exhaust? And has anyone been tracking the occurrence of Magothy and sulfur-backed creeks?
Well, so I can answer that about mahogany tines and sulfur bacteria. I do keep track of them, and I can say that we had neither this year. Again, I think it had something to do, at least the mahogany tine, had something to do with the fact that it was so fresh this year. We had green algae instead of those ones that cause the red-brown ones that cause mahogany tine. And we didn't have the heat that brings on those, at least we didn't seem to have the heat that brings on those sulfur bacteria blooms this year. It seems like that's one of the main reasons why we get them is that very high heat in the creeks. And we didn't see that this year. So I do keep track of them. And what was the first part, Tom? What was the first part of Tom's question? Sorry, he can't speak. He's muted.
Yeah, it was any focus on nitrogen deposited from auto and small engine exhaust.
Yeah. I don't know who's doing that. I'm sure there are nitrogen oxides that are released, but I don't know anyone who's tracking that. Maybe somebody is. Anybody from the county know if anybody's tracking that? Yeah, I don't know. Good question, though. Good project.
I'm not aware, maybe from the county, but I'm sure Eric probably knows. I'll let him know.
Right. Okay.
Okay, I've got a question from Craig Myers who wants to know how long has Lake Waterford existed?
Oh, Paul knows about the history of Lake Waterford.
I do a little bit of it. Actually, it's the first county park, believe it or not. And before that, it was a private park. And before that, it actually was an oddball that they grew exotic plants. I can't understand how that happened, but that's what they did. And before that, it was always a mill. Yeah. So it was a mill in the 1800s and 1700s. In fact, if you go to Lake Waterford Park and you go to the tennis courts, and I say the south or the northeast corner of the tennis courts, you will actually see the millstone half buried in the ground right there. So Lake Waterford has been around, or at least the mill pond's been around since the 1680s or so.
Oh, that's interesting.
And by the way, when Bayland, I think it was Bayland that did the evaluation about Lake Waterford as a precursor to the county, to the dredging project, it was known that if the county didn't do anything, Lake Waterford would be I think half full in 7 years from now.
Right.
So it's acting like a holding pond, and periodically holding ponds have to be cleared. And Sally and I both declared it a pollution source, and I applaud the county for stepping up and fixing it eventually.
Okay, we've got a question from Steve Miller who says, there have been dozens of stream restoration projects in the Magothy River watershed, and stormwater BMPs have been installed in a large number on private and commercial property with a measurable impact on water quality in the bay.
Yeah,
My
yeah.
answer to that is that really it's the impact is more localized. Berrywood's a perfect example of a localized impact. If you're thinking that you're going to be able to put, 2 bags of oysters at the end of your pier and see the bay clean, is not enough in the numbers. So these restoration sites, Berrywood's an excellent example on how you really enhance the local habitat, the local fauna, and actually improve the water quality within that site. And as you do more of them, you will have a little bit more around, but sometimes I think our expectations are much higher than the amount of things that we want to do.
Yeah, and there have been studies done to show that, down just a short distance downstream from the site, they're not seeing an improvement in water quality. But all of the fresh water that flows into the river is coming from these little tribs. And if we go after these little tribs that are in the most trouble, as the county has been doing, and some of the private projects have been doing, then the hope is that, that water that's entering the river, we'll begin to see more of an impact on the river itself. But as Paul says, it's going to take a long time before we see the impact on the main stem. Right now, we're seeing the impact locally, and hopefully later we will see it to be more spread out throughout the river.
My thought about that too is it encourages other groups and other communities to move forward with restoration because they see the value in their local community and see the value. And then when they see that value, then they're going to be more open to larger projects that will have to happen if we're going to really address the issue and to reverse some of the trends that we have. So it's a 2-step process.
Right.
We're down to the last 2 questions. There's a question from Nina Tracy. Why isn't there a state-funded pump-out boat on the Magothy?
Well, that's a good question. I saw that this morning, and I don't know why. I have a suspicion it has something to do with funding, but I will check into that. I don't exactly know why. I know in Annapolis they do. I don't exactly know if it's funded by the state. I know in the West River organizations, I believe, fund their own pump out boat. I don't believe that it might be something that MRA could do because we just don't have those type of volunteers that would like to do that. So I don't know. I will check. It's a good question. We certainly have the recreational value on the river as good as any other river.
Right. Also, I think, the places where you really need a pump out boat are places where you have a lot of liverboards. And I don't think, at least in my visiting of the marinas on the Magothy, there are very few liverboards on the Magothy. So that the people who are going out and have heads on their boats are generally going out on, weekend or day trips. And they're going to be able to stop at a pump out on their way in or out and do the pump out. I'm not sure that we really need a pump out boat in the Magothy. I don't know.
I look at it too because of there are very few. I know there's one at Ferry Point. I know there's one at Manhattan what is that? Not
Magothy
Mag-
Manor. I mean Magothy Marina. Mhm.
Magothy Marina. I go there all
Yeah.
the time. I'm not sure how many other marinas have those pump
There's
out
one up at the
stations.
Atlantic Marina at Gray's. They have one up there.
Okay.
So we have a few at either end of the river there. Yeah.
So it is, and we do have a number of weekend users. So I don't know. I will ask around. It's a good question, but I'll ask.
Mhm.
All right, last but not least, one of your favorite topics, Paul, yellow perch. Susan Minnemeyer says, I have a question on yellow perch spawning in Cattail Creek and wanted to ask general area. Was it near Berrywood? She has looked around Arundel Plaza's dock down to Oakley Forest, but hasn't seen any so far.
Wow. Well, it's interesting. I mean, Lisa, you saw them in your house.
Yeah,
Between your house and
got
mine, we counted
4 or 5 exact.
Right. I counted between our two houses, I counted 13. I went up to Berrywood and I saw the pictures that were taken. I counted 3 up there, but it was a picture that was taken on the other side of the Berrywood restoration that must have been at least a dozen egg sacs up there.
Okay. Well,
sometimes
I'll look again.
Well,
there's that little, there's sort of like a little beach surrounded by forest across from Berrywood, and I'll walk down there too.
Yes, if you look underneath, if you're in Berrywood, now here's
I'm in
the thing.
on the other side of Berrywood. I look at Berrywood from our dock.
Okay, so, well, if you know where the Oakley place home is, right at the end where the swimming pool, right at the end by the boat ramp or by the old boat ramp.
I'm not sure. I'm relatively new, but I walked from just the tide was so low and I could just walk on the shore from the Arundel Plaza dock down to the Oakley Forest dock. And I didn't see any there, but I could, there's also it loops around and there's forest easement on the shore. I'll walk back the other way.
Well, I'm surprised. We have not seen yellow perch spawn in Cattail Creek, eggs anyway, since the early 80s. Now, Sally and I in 2015, we went looking at the end of where the fish ladder was in March of 2025. And we got a picture, and what we saw there really broke our heart was that we saw on the shoreline about 25 filleted yellow perch. And I've always said to myself that probably was the last batch of yellow perch in Cattail Creek that would have made that trip up to the fish ladder at Asbury Road. Part of the problem with that area is that there is absolutely no protection for them. And which is a big difference than at Catherine Avenue and Lake Waterford. That area that's 3,000 feet is protected with no fishing, very tightly patrolled from February to March or to April. So one of the things I did ask the Berrywood people, and we did it today or this time, is that we're now going to be transferring eggs every year from Upper Magothy. We got permission from the DNR to try to restart the yellow perch population inside the Berrywood restoration site. Okay. And by the way, if it didn't have the beaver dam that's there, those fish, if we started there, could swim all the way up to underneath the railroad tracks and beyond in Severna Park. There's nothing other than a few beaver dams in the way, but there's nothing holding them back.
No, the beaver dams are interesting too, because they're also out there trying to engineer things for better water quality. And I sort of wonder if there's some way.
Well, they're Democrats because they build back better. And we had noticed
they'll be back,
at Catherine Avenue, early in the spawn, we were concerned, and the discussion was that we were going to leave the beavers there because that's a natural animal and that's their natural habitat. But they are so efficient that they actually blocked the yellow perch. And I had to make a call to the DPW, and they came up and undid the dam.
Right.
And I thought we would lost the whole perch spawn this year, but they did it soon enough. And the yellow perch, by the way, Susan, is only about a 48-hour window.
Right. So they've already
They're
come
done.
and done their
They're
thing.
pretty much done.
Yeah.
And
But there is
one of
actually
the
still
things that-
around.
yes, one of the
yeah.
things that Sally and I are kind of interesting to see is in the cages that we put in, whether the eggs would not be so silted in. And I'm
Mhm.
happy to say that the weather conditions were favorable. And I looked at Berrywood's eggs in the basket, Sally, the other day. They look pretty good.
Good.
Mhm.
And they also look pretty good up at Lake Waterford. So
This is funny. The
we're
last
really
2 days
excited.
we had ospreys with very big fish flapping around that they had just caught right at our dock tube, which I hadn't seen, like feeding that far up in uncattailed
Well,
creek. I mean,
ospreys would be
there's a
feeding
lot
on
of
probably shad or gizzard shad, that kind of thing. But we're on my things to do list. I kind of got sidetracked with Mount Misery, and I kind of got sidetracked with beavers. And then I kind of luckily got the spawn in, and we marked it. But next year or the following year, we are in the process of building a trail. And when we do see the spawn, I'm going to tell people to bring their kids, because it's very impressive. It's just the most amazing thing that you could ever have is to watch these fish work their way up in such numbers in little time. And the Lake Waterford stream is only 6 feet wide, if the largest part of it.
Oh.
So I am thrilled. I'm sorry we had such a rocky beginning, but I think we had a pretty good program, and I appreciate everybody that came out tonight. And I appreciate my executive board, and I appreciate all MRI volunteers. And I appreciate, give everybody a round of applause and Sally for doing such a wonderful job putting this together. So, you know, I wanted to show two little videos, but we just can't get to it. But one video I really wanted to show tonight as an end, and we got a video of yellow perch swimming on their side, literally swimming in less than maybe 2 inches of water up a hill. And all I could think about is there ain't no mountain high enough. So I want to leave you with this thought that we can, working together, we can restore, and we will restore the Magothy. There ain't no mountain high enough that we can't do it. So let's take that positive note and carry forward.
Okay, sounds good. Thanks, everybody.
Thank you.
Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.